Okay, welcome back. This is Chapter 6. And as always, we're going to kind of go through the objectives really quickly to make sure we're covering everything. So turn to page 248. It says, describe the various computer and mobile device cases and the contents they protect. Describe multi-core processors and the components of a processor. Identify characteristics of various personal computer processors on the market today. Explain the advantages and services of cloud computing. Describe a bit and describe how a series of bits represent data. Explain how programs and application instructions transfer in and out of memory. Differentiate among various types of memory. Describe the purpose of adapter cards, USB adapters, things of that nature. Explain the functions of a bus. I thought that's how you got to the grocery store. Explain the purpose of power supplies and batteries, and understand how to take care of computers and mobile devices. Okay, so this is kind of be like a Tinker's kind of a chapter where we're going to crack open a machine and peek and see what's on the inside. Don't actually do that, really. Certainly not while you're watching my video. Okay, so let's basically start with what are we talking about? So I mentioned to you guys before that sometimes you have a computer with a physical tower box thing. And what you call this is complicated because some people call this box the CPU. And that's probably not correct. Some people call that the computer. You know, it's just confusing. Particularly if you have an all-in-one computer where the components of this are actually embedded into the frame of the display. So instead of having two, display and this thing, they just sandwiched them together. So now you don't have two boxes, you only got one, and it's a little complex. Anyway, bottom line is, when people talk about, turn on the computer, typically you're talking about that thing, not the monitor. Unless, of course, you have an all-in-one where it means the same thing. Laptops, tablets, convertibles, media players, blah, blah, blah. You guys know what all that stuff is. So if you were actually to peek inside this guy, not that guy, because that guy doesn't have any user serviceable parts worth a dang. But this guy has lots of open space, and it's designed for you to plug in stuff. So let's take a peek. So here's the inside of what my computer might look like. And so I probably have a video card, and it could be a video card, my graphics processor, could be on the motherboard. We haven't even talked about motherboard yet, but just bear with me. It could be part of the system board, or it could be a discrete card that plugs in. And so in this particular picture, this is a discrete video card that plugs into this. So my computer has a power supply with a noisy fan. It's got a video card, it's got a sound card, it's got a place to plug in a processor. And the processor can't sit by itself, it needs to be cooled because them suckers get warm. And so we're going to have a heat sink and a fan to cool this little guy down. And then we're going to plug in memory. So this is what the inside of my computer looks like. Laptops are a little different because you rarely ever crack a laptop case open, okay? So if you ever did, well, it'd be the same thing, but they'd be a little squashier and flat. There's hardly ever a scenario where you're going to crack open a laptop and add a card. Very few. And so yeah, it's going to have a processor, and it's going to have the memory modules, but they're physically going to be smaller. And then you're going to have a different type of heat sink and fan that's just physical. I mean, I've seen heat sinks and fans, about the size of a grapefruit. I mean, monstrously huge things. Which clearly wouldn't work for a laptop. Okay, on page 250, they talk about the motherboard, and so the motherboard is the basis of your computer. If you were to build a computer from scratch, what you would do is you would buy a case, typically a metal or plastic case. You'd buy a motherboard, you'd buy a CPU, and the CPU would probably already come with the cooling fan already on it most of the time. You'd buy memory, and you'd buy any type of peripheral cards, and you'd bolt all this stuff together. So a power supply, you'd mount in the case, you'd hook up to the motherboard. CPU, you'd hook up to the motherboard. The video card, you'd hook up to the motherboard. Everything hooks into the motherboard. The memory chips hook into the motherboard. So it is the mother of your computer. Big thing. Once again, you'll never actually see the guts of your laptop motherboard, so why bother to show you a picture? You'll never see one of these guys, not unless you're going to be a tinkerer. Okay, on page 252, they talk about what the processor actually is. The CPU, the Central Processing Unit. Okay, most people just sort of call them processors now. I don't know, CPU just kind of fell out of favor for whatever reason. Anyway, it is the brains of your computer. That's where everything takes place. And there are a gazillion choices. I mean, a gazillion. You think, oh, well, I'm going to get me an Intel processor from my computer. Well, yeah, but you probably got a dozen or more to choose from. Now, the problem is, when you buy a motherboard, it's going to have a particular type of socket. And so if you have a socket that has, 1152 pins, then you're going to have to buy a CPU that has 1152 pins to plug in. Okay, makes sense? So you can't just buy any processor you want. You have to buy a particular processor that fits a particular motherboard. They are matched, pretty much. Okay, so they have multi-core processing, which means inside the chip. Okay, inside the chip, and chips are about 1.5 by 1.5 big. Okay, very thin, but kind of not that big. Inside the chip, there's actually going to be multiple processors. I know it sounds weird. So inside my processors, multiple processors. See how the words get a little confusing? So it's actually easier to say inside my CPU chip is 2 cores, processing cores. Now the semantics makes a little bit more sense. So inside my CPU, I have 6 processing cores, or 4 cores, or 2 cores, or whatever it is. And all this is they are processing units. It's just they bundled them together. It's like no different than going to the store and saying, buying 1 egg or buying a carton of eggs. Right? It's still an egg. You're just getting a whole carton of eggs. It's no big deal. Okay, so multi-core is all about inside a physical container, there's more than 1 egg or processor. I'm going to skip over some of the diagrams they have in the book about, the CPU cycle and all the rest of that stuff, the control unit and the arithmetic unit and all that, and processing instruction. Unless you're going to be a geek, that's not a very appropriate chapter for this class. And they talk about the processor contains registers and system clocks and all the rest of that stuff. All you basically need to know is that the clock speed of your processor is one of the measures of how fast your system is going to be. So if I have a system that has a 3.2 gigahertz processing speed with 2 cores, then I have another processor with 3.2 gigahertz processing speed with 4 cores. Well, the one with 4 cores is probably going to be faster for doing certain types of things. Now, it's not true that there's a doubling factor, okay? Having a machine with 4 cores is not twice as fast as having a machine with 2 cores, okay? I'm sorry, that's just not the case. But under certain types of loads, it is extremely helpful. On other scenarios, it provides no impact whatsoever. If you have an old game that you love this particular game and it was written years ago, and it was written with only 1 core in mind, it's only going to use 1 core. You might have 18 cores on your machine, and you're only going to be using 1 of them. So in that particular case, it will have the exact same performance as if you had a machine with 1 core, because it's only using 1. Okay, that's the only thing you need to know about cores and clock speeds. Okay. There's a really cool tool that you can download, and this tool is called CPU ID. Okay, that's the name of the little utility. And what it'll do, it will tell you everything you ever wanted to know about your processor but was afraid to ask. I'm just going to run this guy. And what it's going to do is it's going to look and tell me what I've got. Well, I've got an Intel Core, and I've got a socket 1366, which means my processor has 1366 pins on it. I know, which means my motherboard has to have 1366 spots holes for those 1366 pins to fit into. And it talks about, I'm running at 3.2 gigahertz, and here's all the features that are turned on, and it goes on and on and on, and what the clock speed is currently running at. Okay, so that's kind of a cool way, and this is a free utility you can download, and you can basically ask, find out more about what type of chip your system has. Kind of cool. Okay, let's continue. Okay. So on page 256, they're talking about the processor itself generates a great deal of heat. Now, in the old days, if you were to just plug the CPU in and forget to hook up the fan, okay? Now, I know people have done this. They bought the CPU and it came with a fan, but it wasn't physically attached. And so they just took the CPU and plugged it in their motherboard, and without even thinking, right, they just left the fan and heat sink off to the side, turned on the machine, and it was destroyed within about a second. Okay? It got that hot that quick. Within a matter of 2 seconds, their processor was toast. It had blown up because of heat in 2 seconds' time. Now, almost all processors that are run today have a thermal limit in them. And so instead of a puff of smoke coming out of it and you throw it away, it just turns off. It'll get hot and it'll just say, and just turn itself off, and all you have to do is wait for it to cool back down and pray, and then turn it back on and it'll be okay again. All right, so it's thermal protection to prevent you from doing anything goofy. So when you're installing a CPU, you're going to have to put in a heat sink and to suck the heat out of the processor, and then a fan to dissipate that heat throughout the rest of the system. Okay. Now, heat sinks are kind of cool, but the fans are noisy. I don't particularly like a noisy room. So some people go with water cooling. And the water cooling is just like your car. In your car, you have like a water pump, right? And you got a radiator with fan. That's what this machine has. You can buy a machine that has a radiator with a fan blowing on it, and pipe that comes out of the radiator and goes to the processor, comes out of the processor and goes to a pump and into a little reservoir, and then it goes into a little loop. And the reason for doing this is you can get more efficient cooling than just a heat sink and a fan, and it's a heck of a lot quieter. So if you're into overclocking your computer, you've probably heard that term, and gamers often do this. They'll run the parts beyond their design specification. They'll buy a 3.2 gigahertz processor, but they'll crank it up to 3.5 gigahertz. And it's very susceptible to heat damage under those scenarios. So they have all sorts of exotic cooling that they can use, liquid cooling being one of them. Okay. If you have a laptop, there's really not much of an opportunity for doing that. They have a thing called a heat pipe that are typically built into laptops. And you can get one of these little goofy, what's called a cooling pad. And it's like you put it in your lap, and you put the laptop on top of it, and it just kind of blows air. Because let's say, for example, you're sitting up in bed, and you have a big fluffy pillow, okay? And so you grab your laptop and just plunk it down on top of your pillow so it's nice and comfortable for you to type. Well, you've probably blocked all the vent holes on the computer without thinking about it, because a big fluffy pillow would just kind of envelop the bottom of the case. And so your poor old laptop's going to overheat in one heck of a hurry. So you get this little cooling pad that goes underneath that continuously blows air and helps cool things down to prevent you from unintentionally having a meltdown of your laptop because you set it on a fluffy pillow or not. Okay. This is probably a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.